Today we'll start looking at whole numbers. So we're using the book, so the textbook, and also some notes I made. Let me make this bigger. Alright, so we'll look at the first 3 sections in this video. Alright, so whole numbers. So these are the simplest kinds of numbers. Let's look at my notes. The first whole number is 0, then 1, 2, 3, 4, and so on. These are single digit numbers, but to write a bigger number, we're using the decimal place value system. Okay, so this big number is 72,983. All right, so there are 5 digits here. The digit on the right is always represents the number of the ones. Okay, so this digit 3 represents 3 ones. This digit 8 represents 8 tens, 9 hundreds, 2 thousands, and 7 10,000s. All right, so that's our number system. I'm sure you're used to, but you can write out what this looks like. So written out, so you'd never have to write it out like this, but this is it: 3 ones, 8 tens, 9 hundreds, and so on. Alright, the simplest thing you can do with 2 whole numbers is add them together. So for example here, 3 plus 4, a good way to think of it is on the number line. So we're starting with 3. And when you're adding, that moves you to the right. Okay, so start with 3. Add 4 units, you end up at 7. So 3 plus 4 is 7. Yeah, it's easy for whole numbers, but we'll see it's the same principle if you're adding fractions. So whenever you're adding, you just move the appropriate distance to the right. We'll see in a minute if you're subtracting, then you're going left. Some basic properties of addition. Addition is commutative. That means you can switch the order of the 2 numbers, you get the same answer. So if you started with 4 and added 3, you'd end up in the same place, 7. There's a number that you can add on the left or the right, and it doesn't change the number. So 9 plus 0 is 9. 0 plus 9 is 9. So 0 is called the additive identity for addition. So it's the only number with that property. If you add any other number, it's going to change the 9. Okay, so any number plus 0 is just the same number. And one more basic property, addition is associative. Okay, so this is a different idea from commutative, so we're not changing the order of the numbers. Here we have 3 numbers we're adding together. So 3, 5, and 2. So now we're changing the order of which addition we do first. So if we do the addition on the left here first, 3 plus 5 is 8, and then add the 2, we get 10. But if we do the addition on the right first, okay, so we're changing the order of which operation we do first, so this is more about timing. We're getting 7, then 3 plus 7 is 10. Alright, so the bottom line is, if you add three numbers together, it doesn't matter which pair you do first. The pair on the left or the pair on the right. So addition is associative. Yeah, when we look at order of operations, we'll talk about that more. Alright, basic properties of addition. Alright, so you can use the number line to add small numbers, but for bigger numbers, I don't recommend the number line. So for big multi-digit numbers, then put the numbers vertically, so list them vertically, but the important thing is make sure you line up corresponding digits. Okay, so the ones places should all be lined up, all the tens, all the hundreds. That's a basic idea. When you're adding anything, you should be adding like terms. And then just add up each column. If the number gets too big, so if it gets bigger than the biggest digit 9, then you have to carry into the next column. Alright, so this example, 3,185 plus 862. Okay, so we write one number over the other. Usually we put the smaller number on the bottom. Addition's commutative, so it doesn't matter which you put on top. But yeah, so here I haven't done it right. So this 5 represents ones, this 2 represents ones, but they're not lined up. So don't do that. Also here, yeah, I haven't lined up so this is 100, this is 800, so those should be lined up, and the 3 should be in a separate column. Alright, so I see this all the time in homeworks, but this is the correct way to do it. So we've got the ones here, so 5 lined up with the 2, 8 and 6, 1 and 8. There are no thousands here on the bottom, but if you wanted to, you could include a 0. Alright, so this is set up to add. Okay, and this is easy. So 5 plus 2 is 7. 8 plus 6 is 14. We can only write the 4. We have to carry that extra 1. Yeah, so this is 14 tens. You can think of that as 104 tens. Okay, so that extra 1 went into the next column, into the hundreds column. So now we have 10 hundreds. That's 1,000, so we're really writing that as 1,000. Alright, so just if the number gets too big, it has to carry into the next column, and just remember what these numbers represent: ones, tens, hundreds, thousands. All right, and there's more examples in the book. Let's see. Yeah, so here, well, let's do it. yeah, let's look at this one. So 38 plus 47. All right, so it's lined up properly. Yeah, the 8 plus 7 is 15. So write down the 5, carry the 1. And then 1 plus 3 plus 4 is 8. So the sum is 85. Yeah, any harder ones? Yeah, how about this example here? Okay, so we're adding 3 numbers, same idea, line everything up. 9 plus 7 is 16, plus 4 is 20. So we'll write the 0, carry the 2, 2 tens, and then the tens column, so 2 plus 0 plus 7 is 9, plus 6 is 15. Write the 5, carry the 1. So now we have 10, 17, 17 and 9 is 26. Write the 6, carry the 2. Okay, so there are no thousands for the first 2 numbers, but we have 6,000 here, so 2 plus 6 is 8. Alright, so I wasn't able to keep everything lined up. This 8 should be under the 6, but I hope you get the idea. And yeah, so the jargon, when you're adding 2 numbers, the answer is called a sum. Or, yeah, not just 2 numbers, you can add 3 numbers. Add a bunch of numbers, the answer is a sum. All right, next operation, subtraction. Yeah, so the deal is for subtracting, you're moving left. So this is 6 minus 2. So start with 6 and move 2 units to the left. So 6 minus 2, you end up at 4. 6 minus 2 equals 4. When you're adding it to sum, when you're subtracting, it's called a difference. So the difference of 6 and 2 is 4. That's one way to say it. The subtraction is not commutative, so the order doesn't matter. It's not associative either. If you do a subtraction on the left before a subtraction on the right, you'll usually get a different answer. And there's no identity that works on the left and the right. Okay, so subtraction is not quite as nice as addition. It's a bit trickier. How is subtraction related to addition? Well, as we saw on the number line, yeah, so addition, you're moving right. Subtraction, you're moving left. So those are opposite directions. So addition and subtraction, they're called opposite or inverse operations. All right, so if you start with this number, say, and add a number, you get to here, and if you subtract that same number, you'll get back to the beginning. Or if you start with a number like this, subtract a number, then add the same number, you're back to square one, right? So we can use that idea. All right, so subtracting big numbers, we use the same kind of setup. So write the two numbers vertically with the ones lined up. Okay, but now we're subtracting. So 4 minus 4 is 0. 9 minus 7 is 2. 6 minus 2 is 4. And what's happening over here? Yeah, you could think of, it's like a 0 here. There are no thousands, so 3 minus 0 is 3. All right, so we subtracted 274 from 3,694. We got this number. We can check we got the right answer by, if we add that 274 back on, we should get back to the beginning. Okay, so then just if we do this addition, yeah, so we get back to 3694. All right, so yeah, you can check any subtractions with an addition. It's like, yeah, so in this situation, so it's like we started with 3694, we subtracted 274. If we add that 274 back on, we should get back to 3694. All right, so yeah, we went around in a circle. Now, sometimes we need to borrow, so let me change that 4 to an 8 here. So if we try to subtract 278, then we get a problem. So 4 minus 8, we can't do that. That 8's too big. So we need this idea of borrowing. Okay. So the 4 is too small, but we're going to borrow one of the 10s from this 9. So this represents 9 tens. So we're going to borrow one of those 10s. Okay, so that 9 turns into an 8, and that 10, we move it to the ones column. Okay, so that 110 plus the 4 is 14. All right, so we haven't changed the top number. We're just replacing 94 with 80 plus 14. Okay, so we borrowed a 1 from the 9 to make this 4 a 14. And now we can do the subtraction, so 14 minus 8 is 6. Now we have an 8 here. That 9 is gone, so it's 8 minus 7 is 1. 6 minus 2 is 4. And 3 minus 0 is 3. Okay, so that's the idea of borrowing. So we've done this calculation. And again, yeah, we could check that we did that correctly. So if you add the 278 back onto 3416, you should get the original number. And so you can, so that's a good way to check you got the right answer. Okay, so that's borrowing. Yes, something that could go wrong. If that 9 was a 0, then you can't borrow anything from 0. So in that case, you'd have to go further to the left and look at this 6. Okay, so if this 9 was a 0, you'd have to borrow one of the hundreds from the 6. So write this 6 as a 5. you get a 10 here, and then borrow one of those 10 tens. Yeah, so let's take a look at that. Example 11 on page 17. Okay, so how about 207 minus 69? All right, so we see the problem right away. We have 7 minus 9. The 9 is too big, or the 7 is too small. So we need to borrow, but there's nothing to borrow in the tens place. So we have to go over here to this 2 hundreds. Okay, so we're going to borrow one of the hundreds. So 100 is equal to 10 tens, and then borrow one of those 10 tens to get 10 in the ones column. Okay, so again, so we had to borrow one of the hundreds. Okay, so there's 100 left. The 100 we borrowed turned into 10 tens. We borrowed one of those 10 tens, so now there are 9 left. And that 110 we borrowed, add that to the 7, we get 17. Yeah, so it's complicated. But now we can do the subtractions of 17 minus 9 is 8. 9 minus 6 is 3. And 1 minus 0 is 1. All right, so that's the deal with borrowing. Okay, so yeah, we're adding and subtracting by hand. Yeah, of course you can do all these on your calculator, but for this course, we want to do everything by hand. So yeah, just to get a good feel for numbers. You can check your results on the calculator, but try to figure out how it works, these methods. Back to the notes. Yeah, so here, yeah, this is a mistake I see all the time. So this example, we have 93 minus 68. Okay, so the answer is obviously 35. Do you see the mistake? Yeah, so yeah, it's really 3 minus 8. That 3 is too small. We can't do the subtraction. Yeah, so to do this correctly, you have to borrow one of the tens. So we get an 8 and a 13. So it's really 13 minus 8. That's 5. 8 minus 6 is 2. All right, so the correct answer was 25. All right, so yeah, just be careful that you're subtracting the bottom number from the top number. Next operation is multiplication. So multiplication, yeah, one way to think of it is you're just it's just repeated addition. So 2 plus 2 plus 2 plus 2 plus 2. We've got 5 2's. So if you add those up, 4, 6, 8, 10. 5 2's is equal to 10. All right, so 5 times 2 equals 10. And yeah, we're using this times symbol for multiplication. You could also write it just with a dot in the middle, okay, a central dot. Okay, not to be confused with a decimal point. So if the dot is up here, it means multiplication. If the dot is down here, that's a decimal point. Okay, be careful. Yeah, this is an asterisk. You could also have like a star, use that for multiplication. Or here, just put two numbers together in parentheses. So there's no symbol between the two. So two numbers written like this, it means multiplication. Okay, sums, differences. So for multiplication, the word is product. Okay, so the product of 5 and 2 is 10. Yeah, in geometry, finding areas of rectangles, you just need products. So the length by the width. Okay, so the area of this 2 by 5 rectangle is just the number of squares here, so that's 10. And yeah, you can also see from the figure, you could think of this as so here's 1, 2, 2 2s, 3, 4, yeah, 5 2s. But you could also think of it as 2 5s. So here's 5. Here's another 5. So 5 2s or 2 5s, you get the same number, it's the same area. So what I'm trying to say is multiplication is like addition, it's commutative. It doesn't matter if you do 2 times 5 or 5 times 2, the answer is 10. The identity for multiplication is 1. So what number can you multiply numbers by and nothing changes? 1 is the answer. So for example, 8 times 1 is equal to 1 times 8 is equal to 8. So the number doesn't change. Yeah, if you multiply a number by 0, it does change. You get 0. If you multiply a number by 1, it doesn't change. So 1 is the identity for multiplication. 0 is the identity for addition. And multiplication is also associative. So if you're multiplying 3 numbers together, it doesn't matter if you do the left pair first or the right pair first. So 3 times 5 is 15, times 2 is 30. Here 5 times 2 is 10, and then 3 times 10 is also 30. So multiplication's associative. It has this property for any 3 numbers. And let's take a look at how we multiply 2 bigger numbers. All right, we're using the same vertical format. Okay, so it did make a difference with subtraction, which number you put on top, but here I think it's slightly less work if you put the smaller number on the bottom. Multiplication is commutative, so it doesn't matter which you put on top, which on the bottom. Okay, and then the idea is you start by multiplying with the digit in the ones place for the number on the bottom. Any numbers that get too big get carried into the next column. And then once you've finished with the ones, then multiply by the digit in the tens place. And the answer there gets shifted to start in the tens column. So an example, we want to work out 28 times 149. Okay, I'll put the big number on the top, 149, the small number 28 on the bottom, and again everything has to be lined up nicely. Here are the ones, here are the tens, any hundreds go here. All right, and we start with this 8. Okay, so the digit in the ones place on the bottom number. So we're going to multiply 149 by 8 first. Okay, so 8 times 9 is 72. Write down the 2, carry the 7. Next we do 8 times the 4, so 8 times 4 is 32, plus the 7 is 39. Write down the 9, carry the 3. And then it's 8 times 1, so 8 times 1 is 8, plus the 3 is 11. Or write down the 1, carry the 1, but we just get this 11 here. All right, so we just worked out that 149 times 8 is 1,192. All right, don't forget this 2 here. So now we have to multiply 149 by 2, but it's not really 2, it's really 2 tens. Okay, so the answer, well, let's see, so yes, first it's 2 times 9, so that's 18. But it's not really 18, it's really 20 times 9, so it's 180. So that's why the 8 goes here and we carry the 1. Okay, so it's 8 tens, so that's why it's so when you're multiplying by tens, just don't forget to shift the second row in. Okay, so 2 times 9 is 18. Write down the 8 here, carry the 1. Now it's 2 times 4, that's 8, plus the 1 we carried is 9. That goes here. And lastly, 2 times 1 is 2, so that just goes here. All right, so 2 times 149 is 298. 20 times 149 is really 2,980. And then the last step is just add those 2 rows. So it's 2. 9 plus 8 is 17. Write down the 7, carry the 1. 1 plus 1 plus 9 is 11. Write down the 1, carry the 1. 1 plus 1 plus 2 is 4. All right, so yeah, it's hard work, but the answer, so this product 28 times 149 is 4,172. And yeah, you should always, check that answer makes sense roughly. So for example, suppose it was, say, 150 times 30. What's 150 times 30? Well, 150 times 3 is 450, and then multiply that by 10, that's 4,500. So those are two slightly bigger numbers, but we can see we're in the right ballpark. 4,000 and something. So if you got an answer of, say, 417, then you can see that's way too small. So yeah, we're getting used to numbers, and yeah, you should always be looking to see, does your answer make sense? Yeah, maybe an easier version, if it was, say, 100 times 30, yeah, that would be 3,000. But yeah, it's going to be certainly bigger than that. All right, so did we cover everything? Yeah, I guess when you're multiplying, you do need to be familiar with these multiplication tables. Take a look at that. And yeah, more examples here in the book. All right, that'll do it.